Good morning, students. Today we are going to learn about forces and their effects. By the end of this lesson, you will understand what force is, its types, its effects, and how it works in our daily life. So let's begin our lesson. So first of all, what is a force? Students, force is a push or pull on an object. So let's see what is a push and what is a pull force. Push is a force that acts away from the body, while pull is a force that acts towards the body. There are some examples of push and pull forces: kicking a ball, pressing a doorbell, and pushing a swing all are push forces, while dragging a bag or opening a door, these are some pull forces. Students, let's consider some examples of push and pull forces from our daily life. So, pressing a button, it is a push force, while shutting the door is also a push force. Here are some other examples of push and pull forces. Now we will study about the effects of forces. A force can have many effects. It can move an object, it can make the moving object stop. We will discuss the effects one by one. So first of all, a force can make a stationary object move. For example, a powerful rocket uses a large force to launch into space. The second effect of force is that it can speed up, slow down, or stop a moving object. For example, a racing car can speed up or it can brake. Third effect of force is that a force can change the shape and size of an object. For example, a car changes shape during a collision. The fourth and the final effect of force can be that a force can also changes direction. For example, a ball changes direction when it is hit by a bat or any player. Now we will study about different types of forces. There are many types of forces. Some are magnetic force, frictional force, gravitational force, air resistance. We will study about each type of force in detail in our chapter. So, what about the magnitude and direction of a force? First of all, magnitude. Magnitude of a force means how strong the force is. The magnitude of the force is measured in newtons, and the SI unit for measuring forces is also Newton. This unit is named after Sir Isaac Newton, who also discovered gravity. So students, forces are not always same. Sometimes the forces are very large and sometimes the forces are very weak. For example, the force of a cyclone is so large that it can cause a massive damage. So if you want to know that how large a force of 1 Newton is, then it is you can put a weight of 100 gram on your palm. The force or the pull acting on your palm is equals to 1 Newton. So as we have studied that the magnitude of the force can be different, so we measure forces by using spring balance or a force meter. These instruments are used to measure the magnitude of a force. So this is a spring balance and this is a digital force meter on which the magnitude of the force is mentioned manually. How do we represent direction of a force? So students, direction is simply represented by an arrow. The arrowhead represents the direction and the length of the arrow represents the magnitude. A force is measured using an arrow. The arrowhead represents the direction and the length of the arrow represents the magnitude of a force. Consider this example. The arrowhead is showing the direction and the length of the arrow is showing the magnitude of the forces. Okay, consider this aeroplane flying in the air. There are a total of 4 forces acting on this aeroplane. So there is a lift force which is pushing it upward. There is weight which is also a force and it is pulling it downward. The thrust is causing it to move forward and the drag force is slowing down the movement of the aeroplane. All the arrows are showing the direction of the forces, like the weight is acting downward and the lift is acting upward, and the length of the arrows is showing the magnitude of the forces. We can calculate the resultant of the forces simply. When two forces are acting in the same direction, like the arrowhead is showing the direction, and if the two forces are acting in the same direction, we will simply add them up. So adding these two forces will give us the resultant of these forces, like we will simply add these. So 80 Newton is the resultant of this force, and this is the magnitude, and the direction of the resultant force will be the same as the direction of the larger force. So its direction will be in this way. But if we have to calculate the direction and magnitude of the forces which are acting in opposite direction, then we can't add them up. We have to subtract them. So in this case, we will subtract this from this to find the resultant of the force. So because they are acting in the opposite direction, we will subtract them. 50 minus 30 is 20 Newton, which is the magnitude of the resultant force, and to find the direction, its direction will be same as the direction of the larger force. So this one is the larger force, so its direction will be in this way. In a third case, where two forces are acting on a stationary object and the two forces are equal in magnitude, both have the same magnitude, but they are acting in different direction or they are acting in opposite direction, the resultant will be 0. We can mathematically do it. As they are acting in opposite direction, we have to subtract them. So 50 minus 50 is 0. So the resultant force is 0 and this object is stationary and it is balanced. However, in this case, if there are three forces acting on the object, and we have to calculate the magnitude and direction of the forces, we can simply add these two forces, like adding them up will give us 150 Newton, and then the total of these forces is 150 Newton. So 150 Newton and 180 Newton, we have obtained a new picture which is giving us the values of 150 Newton and 180 Newton. So again, the same case, two forces are acting in the opposite direction. To find their resultant, we will subtract them. Thirty Newton. So the magnitude is 30 Newton and the direction is in the same way in the direction of the larger force. So this is the direction. The object will move in this way. Okay, so now we will study about each type of force one by one. So first of all, gravitational force. Students, gravitational force or gravity was discovered by Isaac Newton. He discovered gravity and which lay the groundwork for modern physics. So gravitational force or gravity is simply the force of attraction between two masses. It is similar to magnetic force, but unlike the magnetic force, it can act between any two masses which have some certain mass, but magnetic force only acts between the magnetic materials. Gravitational force is a non-contact force. It means it can act from a distance without touching the surfaces of the objects. Students, we all know that the planets orbit the sun, and this is because of the gravitational pull or the gravitational force of the sun. We know that there are moons of the planets and which revolve around their own planets. So the gravity of the planets hold their moons in their orbits. So it means our solar system is all controlled by the gravitational force. Gravity depends on two main factors, masses of the object and distance between the objects. If the if the masses, there are two large masses that are close to each other, the gravitational force will be large. If there are two small masses that are far apart from each other, the gravitational force will be small. It's mean the force of gravity acts between all objects whether they are close or whether they are far apart. But if mass increases, the force of gravity increases, and if the distance increases, the force of gravity decreases. It's mean gravity has a direct relation with the mass and gravity has an inverse relation with the distance. Now we will study about the gravity on Earth. As we have studied that larger masses have larger gravities, so Earth has a very large mass and it has a very large gravity. The value of gravity on Earth is approximately 9.8 meter per second square. So this 9.8 value is the gravity on Earth. It is because of the Earth's gravitational force that everything falls to the ground. Okay. Newton's third law and gravity. Students, according to the Newton's third law, there is always an equal and opposite reaction to every action. It's mean every action has an equal and opposite reaction. It's mean in our daily routine, a window whenever we push a window, the window pushes back on us. Similarly, when the earth pulls us, we are also pulling back on the earth with an equal force. According to Newton's idea, when we stand on the earth, it pulls us down. So we also pull the earth upward with equal force. That was Newton's idea. But because of the very large mass of earth and because of the very small mass of us, that pull force is not noticeable. But because of the massive mass of earth, the pull force of earth is very prominent. Okay students, imagine if there were no gravitational force. So if there were no gravitational force, objects would float in the air, we wouldn't be able to walk properly, and planets would have move away from the sun. Now we will study about the mass and weight. So first of all, mass. Mass is simply the amount of matter in an object. Mass is measured in kilograms and it remains same whether it is on earth, moon or in any planet. But weight of an object is actually the force of gravity acting on it. So weight is a force, so its unit is Newton, and it is actually the gravitational force acting on an object, so it depends on gravity. So the value of gravity is different in different planets, it is different on Earth, it is different in space. So our weight changes on every planet. Okay, consider this. If a person has a mass of 50 kg, his weight will be 490 Newton on Earth, and his mass is 50 kg, same on the moon, but his weight will be 80 Newton on the moon. We can simply calculate the weight and mass by simple formula. W is equals to mg, where m represents the mass and g represents the gravity. So if a person has a mass of 50 kg and we can calculate his weight by simply W is equals to his mass is 50 and the value of gravity on Earth is 9.8. So we will obtain 490 Newton, which is the unit of weight. So his weight is 490 Newton. But for the same person on the moon, his weight would be different because of this gravity. Because the value of gravity on the moon is 1.6. So multiplying 50 by 1.6 will obtain 80 Newton. So this would be his weight on the moon. Okay, this was about the gravitational force. Now we will study about the frictional force. Students, frictional force is a force that opposes motion and it acts in the opposite direction of the motion. It is a contact force because it acts when the two surfaces are in contact. For example, if you look at this picture, there are tiny projections at the point of contact of these two surfaces. Because of these irregularities, there is friction present between these two surfaces. So friction is mainly produced by the irregularities or the irregularities which resist motion. Friction is also a force, therefore its unit is also Newton. Like other forces, it can also be measured by using a spring balance, which is also called a force meter. So this is a spring balance. We can simply calculate its frictional force by using this spring balance. Uh, what are the factors on which friction depends? There are two factors on which friction depends: type of surface and the weight of the object. Type of the surface can be rough or surface can be smooth. If the surface is smooth, the friction will be less, and if the surface is rough, the friction will be greater or more. Weight. If the weight is greater is the friction, and if the weight is less, friction will also be less. So friction has a direct relation with weight. You can see that a surface which is smooth has less friction and a surface which is rough has more friction. So there are always uses and some disadvantages of everything. So friction is also useful, very useful for us. It prevents surfaces from slipping past each other. It enables us to walk. It helps us to hold a pen. Without friction, we wouldn't be able to walk, or we wouldn't be able to write on our pages, because between our pen and between our pages there are also some irregularities. There is also a friction which helps us to write. Friction also helps to slow down or stop the movement of an object. Like because of the friction we are able to apply brakes. Because of the frictions our cars slow down, and because of the friction between floor and the shoes, we are able to walk. Of course, there are some problems which are caused by friction. So, friction can cause wearing out of our machines, it can cause wearing out of our soles of shoes. Friction is present in machines, and in the moving parts of machines it overheats the machines and produce heat, and this heat uh, lessen the efficiency of the machines. So friction can cause wearing out of our soles, wearing out of tires. Friction can slow down the speed of our bicycles and other moving objects, and friction can cause heat and reduces efficiency of machines. But there is a good news because we can reduce friction. We can simply reduce friction by applying lubricants. We can reduce friction by using ball bearings. And there are, of course, magnetic levitation trains, which these are the trains which uses magnets. So because of the magnets, there is almost no friction and their speed is actually very high. So, and ball bearings, these are the ball bearings which reduces friction, and these ball bearings reduces friction by these allow objects to roll instead of sliding over each other. Okay, if you want to reduce friction, you can apply lubricants, you can apply oils. To reduce the friction of the surfaces, you can polish the surfaces. Simply add wheels so there is a lesser sliding friction, and you can use ball bearings so that uh, there is a lesser friction. So students, today we learned that forces are everywhere. They help us move, stop, and interact with the world around us. We learned about the gravity, we learned about friction, and we learned about forces, their magnitude and directions. So students, that is all. Hope you enjoy your lesson. Allah Hafiz and thank you.